So I'm going to start by sharing my screen and hiding the poll. Okay, so factoring by substitution. We're going to be spending a lot of time factoring the whole rest of the class, basically. And so having enough practice with factoring is going to be very helpful because you're going to be doing it a lot. It's going to be reinforced almost every single week. Substitution is a good type of factoring, a nice little trick when you have the more complicated things to factor. It can make it look like a simpler problem. And if you're someone that has to go on to pre-calculus or calculus, substitution is something that's used a lot in calculus, where you're doing some sort of substitution and then you turn it into a simpler problem and then you turn it back into your more difficult problem. So it's a skill that you're going to need if you have to go on to calculus. So we're going to kind of give you a little refresher of it, or a little introduction to it here with factoring. So first off, what is factoring? And so for those of you who haven't gone through the factoring material yet, this is kind of a little overview for you. Factoring is reversing the multiplication process. So when you multiply polynomials, we do FOIL. Factoring is undoing FOIL. It's taking something that's multiplied out and turning it into things that are multiplied together. And it's a product of factors. And factors are just those things that can go into an expression, or that can divide into it if you think of it. So with numbers, a factor is like a factor of 6 is any number that can divide into 6. So 1, 2, 3, and 6 divide evenly into 6, so they're factors of 6. Factoring means writing that number as multiplication instead. So you can write 6 as 2 times 3 instead of 6. You can also write it as 1 times 6. There's multiple ways to factor a number. When we have expressions with algebra, there's basically only one way to factor it. The order of the factors might differ because the order of multiplication doesn't matter, but what you're multiplying, there's only one way to do that. So that's nicer compared to a number where there's multiple ways to write it. So factoring is basically, we have something that's multiplied out, we're turning it into multiplication, and this is a good skill used for solving. It's very helpful when we're trying to divide fractions that have things with variables. It's very, very useful, so we use it a lot. So there are several different techniques for factoring polynomials, and polynomials are just those series of numbers and variables adding together, basically. So we can factor out the greatest common factor, and that is basically done first. No matter what type of factoring you're doing, you always try to do that first because it makes things smaller to work with. Then there's factoring by grouping, which is generally used if you have 4 or more terms. We've got trial and error, which is also called guess and check, and the AC method. Those are all both specifically for trinomials, which means we have 3 terms, and so you do one or the other. Then we have some types of factoring that we can do with formulas. There's perfect square trinomials that have a formula. A difference of squares has a formula. There's different types of formulas or shortcuts that you can use, but they're only in specific situations. And then we have the substitution method, which also is used in specific situations. So you've got all these different techniques, and the one thing that you need to learn, oh, let me make sure I've got the recording on. Good. Okay. One thing you need to learn while you're doing this is which technique do I use when? And that's something to kind of pay attention to, is what does it look like? Okay, that means I use this technique. What does it look like? Okay, now I use this one. So there's different ways of factoring, and I'm going to be focusing on the substitution method. And after we do the substitution, then I'm going to use the trial and error method. So I'm actually using multiple techniques here in conjunction. So the substitution method of factoring is you're literally doing some sort of substitution. What happens is you have a really complicated looking thing, and you say, well, I've got this thing that's repeated. Instead of using that, I'm going to replace it with a single letter so that it looks simpler. And then you factor. So you've got steps. You have to pick what are you substituting. We usually use the letter U for substitution. I am not sure why that is a letter that we use, but that is just convention that we use U. And so you decide what is U going to be equal to, and then you replace U in those places. And then you factor using one of our other techniques. So we're going to be using trial and error, or you could use the AC method. These are all going to be trinomials. Then you reverse your substitution so that you remove U and you put back in what U was equal to, and then you simplify. So we're going to go through all of these steps in my examples so you can see how this works. So here's an example of something that we want to factor, and we're going to use substitution to do this. Now, this particular problem we can also factor by taking out the greatest common factor, but it may look complicated and it might be easier to look at it and think of it as substitution. So step one is to decide what U is equal to. So we're picking U, and you're looking for the thing that's in common. And so if you're looking at our polynomial here, we've got two terms. We have 3a times 2a plus 1, and then we have the 6 times 2a plus 1. So those are two terms, and we're looking at what is in common. And they both have a 2a plus 1. So that is what you're going to want to set as your U. It looks a little complicated. Generally, whatever you want to set as U is something that has more than one term, but it needs to be in common with multiple pieces. So we're going to say, let U equal 2a plus 1. So you decide what is the complicated thing they have in common that I want to replace. So we're going to use U for that. And then we're going to do our substitution. Substitute in U. So everywhere that I see 2a plus 1, I'm now going to rewrite it with U. So this gives us 3a and then times U instead of the 2a plus 1 minus 6u. So now we have something that looks simpler. And we took something that looked complicated. It's got these things in parentheses, and we've actually turned it into something that's now much smaller to work with. And now you're going to factor what you see. So we are going to factor. So here we have 3au minus 6u. So this is a binomial. There are two terms. That's what makes it a binomial. And generally, when you have two terms and there's no exponents, you're going to factor out the greatest common factor. So the greatest common factor, first you look at the numbers and you're saying, what is the largest number I could divide out of all of the numbers that I see? So I'm going to put this actually in a different color. So we abbreviate the greatest common factor as GCF. So we were looking at the number 3 and the number 6. What is the largest number I can divide into both of those numbers? So feel free to type that in the chat. I like to have things be a little interactive. 3. I see a 3u. So Ryan's going a step further. So if we look at just the numbers, I can divide a 3 out of 3 and a 3 out of 6. The next part is to look at the variables. And they both have a u, so I can also divide a u out because they both have a u in common. So I usually do it step by step. I first figure out the number, and then I figure out the letters, what letters do they have in common. And then that makes your total greatest common factor. So your greatest common factor here is 3u. The greatest common factor of the numbers is 3. And then when you look at the variables, they both have a u in common, so I can remove that. So that's the u. So the way that I factor and is I usually rewrite this as the greatest common factor, and then I take whatever my polynomial is, and I divide it by the greatest common factor. That's how I set it up. You're less likely to make mistakes with like signs if you do it that way. I started setting mine up this way once I actually got into calculus, because when I got to calculus, we had to factor out something that was not a greatest common factor, and I didn't know how to do it. And this is how you would do it. You would set it up this way. So it is possible to factor things out that are not the greatest common factor, and this is how you set it up. So then that's just what I've been doing ever since. So I'm going to put my 3u in front. And then when I say we have the polynomial over GCF, you're basically taking everything that you have and you're dividing it by that greatest common factor. So I split it up as two separate fractions there. So I've got 3u and then in parentheses 3au over 3u minus 6u over 3u. And then you simplify inside the fractions. So you're following your order of operations there. You're following the simplifying expressions that we needed, that you had to learn, where you're canceling out things that are in common. You've got your variables, like with your exponents, you subtract the exponents, that sort of thing. Now we don't have to do any subtracting of exponents right now because they basically all cancel out. So I'm going to just do this in a different color. Like our 3's cancel out here, the u's cancel out, the u's cancel out here. I do have to divide the 6 over 3, but we end up with 3u, and then parenthesis, all I'm left with is a minus, and then 6 divided by 3 is 2. So that's factoring out the greatest common factor. That's step 3. We are not done, because if we go back, we need to do step 4, which is reverse the substitution. So anywhere I see u, I need to plug in what I set u equal to, and then we simplify. So I'm going to go do this on the next slide because I don't have enough room here. But where I see u, I'm going to replace it with 2a plus 1. So first I'm going to just rewrite what we had here. And we said u was 2a plus 1. So step 4 is to reverse the substitution. And this is sometimes called back substitution, because you're plugging it back into the original, what you had. So it's 3 times u, and u is 2a plus 1. I want to make sure that that whole thing is taken together, so I have parentheses there. And then I have a minus 2. And then you would simplify as needed. And that is specifically within the parentheses. So the whole point of factoring is to turn things into things multiplied together. So when we simplify after we plug things back in, we only look within the parentheses. We don't multiply it back together because that undoes what we're just trying to do. So you're only simplifying within each set of parentheses, adding like terms if needed. So we've got 2a plus 1 in one set of parentheses, and those are not like terms because one has an a, one doesn't. And then in the other parenthesis, we have a minus 2. Those are also not like terms. So we don't need to actually simplify in this case. So because we have nothing to simplify. So our final answer would be the step before it. 3 times 2a plus 1 times a minus 2. So this is the substitution process. You have something that looks more complicated. You see what's in common. Make it a specific letter so you have something that's easier to look at. Do your factoring with that easier thing, and then you plug it back in when you're done to get back to the more complicated thing. So you're trying to save yourself some not necessarily work, I guess, but to make it look easier to you so that it's easier to follow. Are there any questions on this example? Okay. So here is the more common type that you'll see where you'll want to do this. So this is the kind of, so you're going to look for problems where you have something in parentheses squared. Those are the type where you want to use substitution, because those are usually done, and they're usually easier if you do it that way. You could try to factor it otherwise. You could try to multiply out the square, do distributive property, add things together, try to factor from there, but that actually ends up being a lot more complicated. So you're going to want to use this substitution, and you're looking for, again, what's in common here. And we've got this a plus 1. And so that's what's in parentheses, that's what's in common. So that is what you want to use as u. So step 1, pick u. And so we look at what is in the parentheses that's in common. And so we let u equal a plus 1. And it's always good to write down what u is equal to, so that way you remember it later in the, when you get to the end. Because if you get to the bottom, you're like, crap, I have u, but what was u? If you write it down very first thing, then you can always refer back to it. So step 2 is to do the substitution. And we need to pay attention to our variables, our exponents. So I have a plus 1 squared, but a plus 1 is u, so now this is u squared. Then I have minus 10u, so now a plus 1 is u, plus 25. So this is why I'm kind of color coding or highlighting what u is equal to, so I know where I need to plug in my u, what is getting replaced. So you can see that it's in the first two things, not the last one. So now this is a trinomial, so this is where we want to either factor by the AC method or guess and check or trial and error, whatever phrase you prefer. When I see something with no number in front of the squared term, I always do trial and error because it's faster. I only use the AC method if there's a number in front of that first term thing there. So we don't have anything in front of the u squared, so that is basically a 1. And so I'm going to use trial and error. So when we have a trinomial like this, actually let me get back to the yellow. So it factors to 2 sets of parentheses multiplied together. So for those of you who haven't done the factoring part yet, I'm going to kind of walk you through it right now. So inside these set of parentheses, we have 2 terms. So I'm basically filling in something and something, something and something, and then there's either a plus or a minus in between those. The first spot in each set of parentheses needs to multiply to the first term in our trinomial. So we have to multiply 2 things together to get to u squared. And generally for u squared, for anything squared, it's just that variable times itself. So it's going to be u times u. The last numbers there, the second position, the last position in each set of parentheses multiplies to the last number, 25. Now, to multiply to 25, we have 5 times 5 or 1 times 25. So we have 2 choices there. So we need to determine which is the correct choice. And we determine that based off of the middle term, because the 2 numbers need to add up to the middle. So whatever 2 numbers I pick, they need to add to 10. And let's look at the signs. If I'm multiplying to a positive and adding to a negative, the only way to multiply to a positive is if they're both positive or both negative. If they're both positive, those 2 numbers add to a positive number. We need to add to a negative. So both numbers need to be negative so that they can multiply to the positive and add to a negative number. So I'm going to put a minus here. So that helps me determine what my signs are. So I know that I'm going to have 2 negative numbers. And so my choices are 1 times 25, which that adds to 26, not 10, or 5 times 5, which adds to 10. So that is our answers here. So the 2 numbers are 5. 5 times 5, or negative 5 times negative 5 in this case, gives you a positive 25. Negative 5 plus negative 5 gives you a negative 10. So we just factored that with trial and error. So then step 4 is to reverse the substitution, or to back substitute, because we factored. So now we're going to plug it back in. So I have my parenthesis, and then I have u. U is equal to a plus 1. Then I still have my minus 5. So you want to be careful that you don't forget, the things that are not u. You still have to have that minus 5. And then second set of parentheses, again, we have u, which is a plus 1, and then minus 5. So I'm going to move up here. So then the last step is to simplify inside the parentheses. And we do have some simplification to do here because we have 1 minus 5 that we can do. So we can simplify this. And so you basically just add your like terms. We have a, and then 1 minus 5 is negative 4. So I have minus 4. And then second set of parentheses, it's exactly the same, a minus 4. And that is your final answer. So if we look at our original problem, we had this thing that looks awfully complicated, but you do this substitution, which turns it into a much simpler problem, which then it's easy to factor, and then you plug things back in, and that gives you your final answer in the end. Are there any questions on this example? Okay. So here's another one. And so again, it looks similar in that we have something squared, we have something not squared, but we have these things in parentheses. So step one is to figure out what are we going to set as u. So I would like you guys to type into the chat, looking at what we have, what are we going to set u equal to? Got a couple answers, 3, 4, x minus 5. That is exactly right. So we want to set it as x minus 5 because that's the complicated looking thing. It's in parentheses. It's got squares. So step 2 is to do the substitution. So when you substitute here, don't forget any numbers that you have in front. So we've got a 2 and then the thing in parentheses that's squared. So the x minus 5 squared is going to become u squared. And then I have plus 9u and then plus 4. So we did our substitution. And then step 3 is to factor. Now, this factoring at this point, you could use the AC method because we have a number in front of the u squared, or you can do trial and error. When I see small numbers like this, I usually do trial and error because it's actually faster. There's not a lot of choices versus if they're larger numbers. Like instead of 4, if I had like 16 or 32 or something like that, or if, you know, instead of 2, if one of the numbers out of 2 and 4, the first number and the last number, if both or one of them is prime, there's not a lot of choices. But if they're not prime, like if I had 8 and 4, that's a lot more choices, and so then I would use the AC method. So if you're somebody that's wondering, well, how do I know what method when? This is how I tell. As I look, do I see, are either of these numbers prime? Because if they are, there's only one possible choice, and it helps narrow down the things when I try to guess and check. So 2 is a prime number, so there's only 1 times 2 that gets there. So that narrows down my choices. So that's why I'm going to do guessing and checking. So I've got my 2 sets of parentheses. And I said 2 and 1 are the only way to multiply to 2. And then I'm going to have a u in each spot. So 2u times 1u gives me 2u squared. Now, I am multiplying to 4 and adding to 9. I'm multiplying to a positive, adding to a positive. That tells me both numbers have to be positive. So I can write those plus signs in there. So now I'm just looking at 2 numbers that multiply to 4, and then the combination has to add to 9. And when I say combination, I'm looking at the outside and the inside numbers. Those have to add to 9. So to multiply to 4, it's either 1 times 4 or 2 times 2. And so you just have to do a little bit of very small mental work here to say, okay, I've only got 2 choices here, and the order of them could matter, but you're looking at how am I going to get to 9? And so I look at this and I'm like, well, 4, because 4 times 2 is 8. And then the 1 times 1 is 1. 8 plus 1 gives me 9. So there's not a lot of choices, and it's easy enough to kind of look at mentally so that you can see, oh, okay, this is where I have to put the numbers in order to work out to 9. So this factors to 2u plus 1 and 1u plus 4. So next is to back substitute. To basically put replace u with x minus 5. Great question. What would happen if 1 and 4 were switched? So that is an excellent question because the order here does matter. So if I switched the 1 and 4, so that let's say 4 is here and 1 is there. If I multiply the inside, 4 times 1 is 4. And I multiply the outside, 2 times 1 is 2. These add up to 6. So if you switch the 4 and the 1, or the 1 and the 4, they don't add up to 9 anymore. So the order that you put these numbers in does matter. You have to put them in the right place so that when you add them, after you multiply, they get up to 9. So this gives us 6, which isn't the number we want. So that tells me, okay, I got to reverse them. So that's why it's called kind of guessing and checking, or trial and error, because you do kind of have to put them in a place and then make sure they add up to the right number. But it's like if you have small numbers like this, there's not a lot of choices. And you can kind of do it in your head, especially when you do enough factoring. It gets a lot easier to do that in your. I just wrote the numbers in the same spots. It didn't actually reverse them. There we go. But if you do enough of it and you get kind of good with your mental math, at least with like your multiplication and adding to small numbers, you can do it pretty quickly. So that was a very good question. So, and that's actually leads us, if you're not sure if you factored correctly, you can FOIL it back out, do the FOIL process first, outside, inside, last, and see if you get back to where you started. So you can always check your work. And if it doesn't match, then you messed up. So you can always check your work with factoring to make sure you get back to where you started. So I'm going to back substitute. So now we have to be really careful with parentheses because it says 2u, and u is x minus 5. So because u is more than one thing, I have to have that in parentheses. And then I have plus 1. And then I have 1u. Well, I don't have to multiply it by 1, so I can just put u. And then I have my plus 4. So you do have to be careful when you substitute it back in, especially when you have numbers in there, because you have to make sure that you put it with parentheses so that you multiply the correct things out. And then we simplify inside the parentheses, but we don't multiply. So what that means is for the first set of parentheses, I have this 2, and then in parentheses x minus 5. So I have to distribute that first. So I'm going to have 2 times x, and then 2 times negative 5, which gives us a negative 10. And then I have this plus 1. And then I could do each set of parentheses separately. So I can do the minus 5 plus 4, which comes to negative 1. And then I have this negative 10 plus 1 that I need to add. So that's 2x minus 9, and then x minus 1. And so then once you've added your like terms, that is your final answer. So some people might find color coding really helpful, whether it's with highlighters or you know, whatever. So maybe you know, color code. Okay, so x minus 5 is going to be green, and then maybe you use green for these parts. So that way you can replace each color, you know, if you kind of color code it, and then you can kind of follow that color coding all the way through if that's helpful for you. So that you remember that, okay, I need to go back, and then you can say, okay, now u is x minus 5, and again, use that color coding. And that might kind of help you visualize it if you're matching the colors, and you can kind of start seeing the patterns there. So that might be helpful for some people. I am a big proponent of colors and color coding where it may be useful for you. Are there any questions on this example? Okay. So here's another one. We've got 2, and then in parentheses, w squared minus 5 plus w squared minus 5, and then minus 15. So what is going to be our substitution here? Feel free to type that in the chat. What are we going to set u equal to? W squared minus 5. And that is correct. So even though it has like a w squared, it doesn't matter. It's still, that's the thing that's in parentheses. That's the same. So that's what we're going to be doing. So don't let that w squared kind of throw you off. So now after we do that substitution, so I want you guys to actually replace that with u. What is our expression going to look like with u in it? So what would the next step look like? Two u squared plus u minus 15. Several people all coming in at the same time. That's great. 2u squared plus u minus 15. Perfect. So we've done the substitution. Next is the factoring. So I'm going to do the factoring step just since several of you haven't gone through all the factoring. You need all the practice you can get. So again, we have that 2u squared. So that's going to be a 2u and a u. Now let's think about the signs. We're multiplying to a negative 15. So to multiply a negative, you need two numbers of opposite signs. So one's going to be positive and one is going to be negative. And then we're adding to a positive. What that means is that if they have opposite signs, you're adding to a positive, the bigger number generally gets the positive sign. And then the smaller will get the negative. But we do have to take into consideration the 2 that we have there with the 2u. So I have to do, let's see, my numbers that multiply to 15. You've got 1 times 15 and 3 times 5. So not a lot of choices, which is good, which is why we're doing trial and error. And you need to get a combination. So because they're opposite in sign, they're going to subtract. And we want to subtract them to get to 1. So like if I say, let's say 5 and 3, 2 times 5 is 10, and then 3 times u is 3. If I subtracted those, 10 minus 3 is 7. That's not what we want. We want 1 because we want a single u. So then I could try to change the order. And so now the outside ones, 2 times 3 is 6. The inside is 5. 6 minus 5 is 1. So I have to make sure I'm subtracting 5. And so I'm going to then have a positive with the 3. And when I say that if we're adding, is multiplying to a negative, adding to a plus, the bigger is positive in the fact that the bigger when you multiply. So 2 times 3 gave you 6. 6 is the one that has to be positive after you do the multiplication. So it's not necessarily the numbers that you plug in, because you have to take into account that other 2 there. So when you multiply this, this gives you a 6u on the outside and a negative 5u on the inside. Those add to 1u. And the -5 times 3 gives you -15. So we've done our substitution. So we've factored. Now we need to back substitute by putting the u back in. So I encourage you guys to finish the rest of the problem on your own, and then when you get to your final answer, type it into the chat. I am also going to work it out here on the screen, but I encourage you to try to finish it on your own. Plug in the w squared minus 5, do the simplifying process, type your answer in the chat, and then we'll see. You can look to see if it matches what I write on the screen. So I'm going to go do this on the screen, but I want you to do it on your paper as well to get that practice. So if you're not comfortable at that point, you can just kind of follow along with what I'm writing. Okay, David's got 2w squared minus 15, w squared minus 2. That actually matches with what I have on the screen. So if you're not at that point yet, that is fine. This is the first time you guys are doing this, so you're not going to be as fast as me or as quick. But that is the correct. So we've replaced the w squared minus 5. We have to distribute. We add our like terms. Now, one thing to worry about when you have a w squared or you have anything squared, you need to double check, can I factor those further? Like, can 2w squared minus 15 be factored? Or w squared minus 2 be factored? These cannot be factored, but there is the section after this one where you learn about substitution, where you learn the difference of two squares, and you learn which ones can be factored. But neither of these can go further, so this is your final answer. And so you can just double check. If you made a mistake, it's probably in forgetting the minus 5. It's probably in forgetting this minus 5 because you already had the minus 5 part of the w. I almost forgot that minus 5 myself because I already wrote minus 5. So those are places where, you want to be careful that you haven't forgotten everything, and so color coding might be helpful. Are there any questions? Okay, so I've got 2 more examples, and these are different. These are totally different types that you may not realize you can do substitution in, because you don't see parentheses and things in common here. So we've got 3y to the 6th plus 11y cubed plus 6. So this is something that you can factor by guess and check. You can use the AC method on this, but you can also use substitution. And a lot of people don't use substitution on this, but I think using substitution actually will make it easier for a lot of people. So that's why I'm going to show how you can use substitution on this. So the key here on using substitution is to look at the exponents. in order for this to work, the exponents have to be double. So the higher exponent needs to be double of the middle exponent, and then there has to be 0 exponents on the last one. So like the last thing needs to be like a y to the 0. There's basically no exponent. So that is the rule in order for this to work, is that first exponent has to be double the middle exponent, and then there's no exponent on the third part. So if you have that pattern, then you let u be the middle part. So u is going to be y cubed. And this actually is the same thing we've been doing, where our u in these previous examples was basically that middle part of the parentheses. We set it as the w squared minus 5 here, the x minus 5. So we're following the same rule where your u is the middle, but it looks different because it doesn't have a set of parentheses. Then what you need to do to double check that this is working out correctly is that you need to square both sides. So if I square u, that gives me u squared, but then I also need to square the y cubed. And your rules of exponents say you multiply those. 3 times 2 is 6. So you have to double check that the first term is going to be u squared. So you set this middle thing as u, and then you square it, and it better equal the next part. And so that's why you have to have it kind of double, because you're multiplying it by 2. And it's always good to double check that it works out. So you're kind of substituting u and u squared to make sure that you've got them correctly here. So when you do your substitution, we end up with 3, and instead of y to the 6th, it's u squared, then plus 11u, and then plus 6. I'm actually going to color code these because we've got it without the parentheses, it's almost harder to keep track. So I'm going to just color code those u's in. So what we've done is we've taken a problem that has an exponent of 6, and we've turned it into something with an exponent of 2 that we know how to factor. We know how to factor something that's squared. We don't necessarily know how to factor something that's to the 6th. But we can only do this in this particular instance where that highest exponent is double the middle exponent, and then there's no exponent. So it only works in certain circumstances. But once you've determined that you can do this substitution, then we go through and we do our factoring and you do everything else. So we're going to factor this. And to multiply to 3u squared, 3 is prime, so that's going to be 3u and u. Now I have to kind of figure out my number portion, so I need to multiply to 6. So my numbers are 1 and 6 are 2 and 3, and I need to add to 9. So I'm going to try 3 and 2 here. And everything's positive because we're multiplying to a positive, we're adding to a positive. So just to double check, I did 3u times u is 9u. So that gives me 9. 2 times u is 2. You add those, we get to 11. So that will give us our 11u. So I've just kind of double checked that my numbers are getting to the middle number correctly. And then 2 times 3 gives me 6. So I've just mentally, not really mentally, I've just double checked that. So now that I've factored, I need to replace u with the y cubed and then u squared with the y to the 6th. So, and we don't have any u squareds here, so it's literally just the u. So instead of 3u, it's 3y cubed. And because it's just one thing, we don't need parentheses there. And then we have the plus 2, and then parentheses, we have a u, so that's y cubed plus 3. And generally, in these types of situations, you don't need to simplify because we don't have a thing with parentheses where you multiply and add. We usually do not need to simplify after this because we're just replacing one term. And so then that would be your final answer factored. So it's a little different because it's harder to determine what u is going to be. And you have to figure out if it's in this particular form. But once it's in that form and you figure out your substitution, doing the substitution makes it easier to do the factoring portion. Because you could factor with the y cubed stuff, but it's just harder mentally to kind of think about it that way. Are there any questions? Okay, so my last example is one that's similar to that one, but now it's got a 4 as the highest exponent instead of the 2, or instead of the 6, but it still fits the rule where we've got the 4 is double the middle, and then there's something without an exponent. So it still fits our rule, so that means we can use the substitution. And we're going to be using our middle part as the substitution. So the x squared is going to be u, because that's the part in the middle. So I'm going to say u is equal to x squared. And then you're going to square both sides. So u squared is x squared squared. You multiply those exponents, that gives you x to the 4th. So that's just double checking that that x to the 4th is indeed u squared. So then we can plug that in. So we have 3, and I'll go back to green. So u squared. Oops. Then we've got minus 5u. And then minus 12. So that's something that's easier to factor than something with these x to the 4th and these x squareds. And this is another one. 3 is a prime number, so it's relatively simple to do guess and check with that. So it has to be a 3u times a u. Now 12 has a little more possibilities here to multiply. So we got 1 times 12. We have 2 times 6 and 3 times 4. So we do have more choices here, but it's not too bad. You know, you don't have, it's not going to take you forever. So I'm going to just 1 times 12, 2 times 6, 3 times 4. So sometimes it's good to write down those numbers so you know what to check. And we have to get a combination. We're multiplying to a negative, so they're going to be opposite. We're going to have a positive and a negative. And the combination needs to get to a negative 5. So we're doing our subtraction again. So I'm just running the numbers in my head, trying to figure out a good combination. And so I just mentally kind of run it into my multiplications to figure out what I need to do. And that would lead me to this combination. So I just mentally said, okay, if I put 12, what would happen if I put 6, you know, and I multiply it by 3, or if I tried 2 times 3 and have that other 6. So I'm just kind of running through the combinations and multiplication. And doing this, 3u times negative 3 gives me, I'll get a negative 9 or a negative 9u. 4 times u is 4u. 4 minus 9 gives us our negative 5u. So I just mentally kind of ran through, figure out where to put the numbers. You don't have to do it mentally. You can write the numbers down, do the multiplication, then like erase, flip the numbers in a different location, try it. You know, you can do that. You don't have to do it in your head. But once I've done that, then I just need to replace u with x squared. So I have 3, and then instead of u, it's x squared plus 4, and then x squared minus 3. And with the x squareds, you would see if you could factor them again using that difference of squares, which is in the next section from this one. But neither of these can be factored further, so that would be your final answer. Are there any questions? Okay, so this is substitution, factoring by substitution in a nutshell. You're substituting and then using a different factoring method and then plugging it back in. The substitution, like doing this kind of thing, is seen a lot in calculus because we do a lot of substitution to make things smaller, and sometimes in the calculus, factoring makes things easier to work with. So this is something that, for those of you who are heading down the road to calculus, you know, this is definitely something that you're going to want to keep notes of, keep in your arsenal, because it's one of these tricks that we use later down the road to make things easier. For the rest of you that are not going to calculus, what this is giving you is just another way to look at a problem, and it's getting you to think about, well, how can I make this simpler and turn in something I've never seen before, and how to turn it into something I have seen before. And so you're still getting something out of it. You may not need to literally solve these kind of things if you're not going to calculus, but the thinking process of trying to figure out what's in common, what can I substitute, you know, just how do I make turn this thing into something I can do, that's important. And that's a good skill for everybody to have, is just trying to figure out, I have this thing I've never seen before. What do I know? Can I turn it into something I've seen? And that's the kind of thinking process that you do on the homework, you do when you're practicing. It's great for the quiz. It's just a really good thinking process to have. So hopefully this was helpful, wasn't confusing you too much. For those of you who had never seen factoring before, hopefully you have some understanding of factoring. So when you go to the factoring parts, you're going to be like, oh, okay, I see what's going on. I did try to explain some of that so that can make sense for you. Any questions on the whole thing as overall or anything like that? Okay, doesn't look